The United States and our allies are concerned about the escalating violence in Syria.
The commander-in-chief said he's pursuing a proposal that would force Syria to give up its chemical weapons.
Cape Ray is on its way to the Mediterranean, where it will take part in the destruction of Syria's chemical weapons stockpile.
There was a civil war going on in Syria, and the U.S. and certainly the world knew that the Syrians had a chemical weapons stockpile. And there was concern in the U.S. about its potential use or falling into the hands of bad actors, as they were called. Our country's policy was, if that occurred, the United States was going to have all options available to respond to such an incident. So that led on December 27, 2012, a meeting here at Edgewood to see what sort of capabilities might exist to get rid of serious chemical weapons. The answer was from Edgewood, yes, we can develop a capability. And the decision was made to develop a hydrolysis system, which came to be known as the field deployable hydrolysis system. And that first unit was designed, built, and ready by June 27, 2013, which is an amazing feat, certainly in just the design, procurement, and fabrication of a unit that fast. World events took a big change in August of 13 with a major chemical weapons attack in Syria. So it was less than a month later that the Syrians came to the table and said, you know what, we'll be willing to join the Chemical Weapons Convention. It was a month later in September that the Russians and the U.S. had their first meeting to sort of develop a framework for how this might occur. The U.S. and others were attempting to establish an international coalition that was really under the lead of the United Nations and the OPCW.
In September, we actually started looking at specific vessels because it was becoming more and more apparent that countries were unwilling to host this technology. It wasn't until November 2013 the decision was made that we're going to implement the technology on a vessel.
Once the decision was made to, all right, let's outfit the ship, which we all know was the motor vessel Cape Ray, that was located in Portsmouth, Virginia. That led to a massive effort to assemble all these individuals to outfit this ship and really have it ready to go by January 1st.
So in just 32 days, basically, we set up on the ship. And then we started what we call dockside operations testing. The operational team deployed to Rhoda in April of 2014, where we did basically on-site training awaiting the completion of the Syrian stockpile to be removed.
The ship's captain was pretty interesting on how he took training. We went through Gumby suits, we went through shoot drills, we went through going down in rafts, a whole bunch of safety life at sea training.
So when we received the chemicals, finally, after waiting 60 days, there was definitely a kind of a sigh of relief because we knew it couldn't end until it started.
We were able to store all the chemical agents and the field deployable hydrolysis system on the main trailer deck of the Cape Ray. But we also had to move liquid effluent around and our reagents around.
There was always the possibility that a military engagement in Syria would preempt the entire operation. There was a lot of international partners playing in that Syrian theater and no way to know when things would break loose, when things would move.
We went into the Mediterranean, and on July 7th we actually started our first disposal of DF material.
Safety was like priority one. We had formations first thing in the morning, first thing with the crew in the afternoon. Safety was crucial.
Probably one of the biggest things that we had to do on a ship is safely move these 1,000 and 2,000 liter containers. And so we had to figure out how to do that safely. These were the chemical agent containers that were delivered from Syria. They're DF, they're mustard. So we had no idea how pure it was, whether there were adulterants in the material, things that were going to compound the problem, and how the chemistry was going to work. These were all on the main trailer deck, but they were in 76 20-foot Connex containers. Those containers had to be safely driven by forklift up to our access area so that we could plumb into them and pump the agent out of them.
We started deliberately on one system first to see what happened when we opened up the first tank and put the first chemicals through the system. And then after several days of operations that way, we split into two crews 12-hour shifts and started 24/7 operations on 2 systems.
The command post was basically where we had monitors that were connected to cameras that were overwatching the chemical operations. When I actually did the mission, I was on the ship, I found that I was using training that had started from the beginning of my career, as when I worked at the Aberdeen Chemical Agent Disposal Facility.
Everyone had every job on the ship. And so if you needed to do something or someone needed help over here, everyone just jumped on board because we were all trapped on this vessel together and no one was going to leave until this mission was complete.
Everybody involved was thoroughly committed to the project. They understood the deadlines, they understood the international implications.
You collaborated and problem solved and established a rhythm to get the job done. You embraced adversity on all levels, from technical troubleshooting to the physical and emotional stresses that tested your endurance.
We became one, like one team, one fight. That's what it was, that was their motto, was one team, one fight.
I learned that we've got partnerships right here in Edgewood that are phenomenal and they need to be strengthened. That group that's starting to be known as the Syrian community have something to bring to the table for these kinds of problem sets, and there's a capability and there are partnerships there that really need to be concentrated on, focused on, strengthened, and used to plan for and potentially implement solutions in the future.
My overall impression of the mission at its completion was that it was a huge success.
We got an entire operation of 600 metric tons completed in 42 days. That's pretty incredible.
In the U.S., we certainly felt like we were getting rid of a very dangerous military weapon. We might have been able to save some lives from these based on what had occurred in that country.
As we go forward and we really look at solving some of the other problems in the ChemBio world, we're gonna have this experience to look back on and say, okay, what did we learn from that, and is there something we can apply so that we're not spending years building a fixed brick and mortar facility, going through a year of systemization, and then starting operations? Are there things that we can do and put into place that allows us to get this done quicker?
Audio Jungle.